there, everybody. Welcome to exercise 8. We're going to go ahead and start this walk through here. First thing to note is that this exercise, we are dealing with elevation data from Mars, which is very exciting, but our base maps that we have here with Earth are not going to work very well because we're not on Earth. So for me, the very first thing that I'm going to do is just remove the base map. Just by selecting these and then removing them. So now we have a blank slate. There's no base map, which means that when we add our data here, this is our digital terrain model and our craters shapefile. Now it's just going to be put on a white surface, and we're not going to deal with any weirdness coming through from, Earth being there. So this is going to be your chance to take a look at the data that we're given, so you can answer your first 8 questions for this assignment. Work through whether this DTM is a raster or vector data, what its coordinate system is, if that's projected or geographic coordinate system, what the default unit is associated with these values, what the resolution is, which I guess kind of gives question 1 away, what our minimum and maximum elevation that's covered by this DM is, and the distance between these 2 craters. So I'll give you a chance. If you're feeling stuck on any of these, remember most of this information you're going to be able to find in your properties. Here in your source tab, now you have your raster information, which will have your resolution. You have your spatial reference, which will have your coordinate system and your units. You can see, the values that are stored in the system, which is basically your minimum and your maximum. And when dealing with the distance here, you're going to want to use your measure tool. Just make sure that it's set to the correct settings here, what you want for accurate measurement. So let's go ahead and actually just set this up real quick. I'm going to use geodesic because that's going to take into account the curve that this is on. I'm going to make sure this is set to kilometers, which is what we want for question 8. Zoom in so I can see both of them. I have a couple different options for measuring here. I can either measure at the edges. That's not what I wanted. I can either measure from edge to edge or far edge to far edge. I personally, I wouldn't do close edge to close edge. I would either do north to north, south to south, or me personally, I prefer to do as close to the center as I can and as close to the center as I can, which is going to give me roughly 6 kilometers. This is extra because I had already measured something with this tool. All right, now moving on, let's go ahead and take a look at this next section where we're creating a hillshade. We're going to come to our geoprocessing tab and, hold on, adjusting the keyboard. Going to look up our hillshade tool in our spatial analysis toolbox. We're going to input our Mars DTM as our input raster. We're going to name our output raster. Personally, I prefer to keep the base name the same, an underscore, which is the only space you should ever have in your names for your files. Dashes, periods, spaces themselves, don't do it. Arc doesn't like to play nice with those. Either keep all the words stuck together or use an underscore. So I'll use the name of the parent file and then abbreviate what the new file is. So in this case, we have our DTM hillshade. Leave the azimuth and the altitude This has to do with angles and like light, because remember, a hillshade is just making things look pretty, so you have a bit of depth to your imagery. So unless you specifically know you're going to be changing these, just leave them. And I'm going to run that. Give it a second to run. Okay, now there we go. So now we have our hillshade, and we're going to want to order these by having the hillshade underneath this and making the DTM transparent. We're going to set it to 50%. And there we go. Now we have a hillshade, adding some depth to and perspective to our elevation data. Next up, what we're going to do is some slope analysis. Give me just a second. Some slope analysis. And keep in mind that this slope value is the steepest slope defined by the cell that it's like specifically for and its 8 surrounding neighbor cells. And you can either get slope as degrees, which would be a value from 0 to 90, or your percent slope, which is your rise over run multiplied by 100. So typically you're going to see much bigger values with that. So what we're going to do is we're going to search for our slope tool in our spatial analysis tools. Going to input DTM as a raster, not the hillshade. That will cause so many problems. Let's make sure it's the elevation data. Gonna follow our naming conventions. And since this is going to be in degrees, I'm going to add degrees there so I know for sure what layer I'm looking at. And I don't have to guess. Make sure that that is set to degrees. And we're going to calculate using planar method. And we're going to run that tool. Remember that anytime you're dealing with a tool and you're not entirely sure what should be going in what box, you have your information tabs that you can open to get some information about what it's specifically specifically asking for. And it'll oftentimes explain the difference between if you choose, like in this case, planar or geodesic, or if you leave a box checked or unchecked, etc. So now that we have our slope file, you can go ahead and answer question 9, which asks what the maximum value with units for your resulting slope raster is. There's a few different ways that you can find this. We're going to find this by coming here to our properties, source, statistics. Here we have our maximum and our minimum. So our maximum is about 72. And remember, our units, we calculated this with degrees, so about 72 degrees. Alrighty, so next up, we're going to be dealing with our craters shapefile. So the first thing that you should do is take a look at the properties and your attribute table, if there is one, so you can get an idea of what kind of data you're working with. This is a chance to go through your source information again for your spatial reference, your extent, any metadata information, or anything else that you might need further down here. Also, our attribute table, we're going to see we have two records. We have our unnamed crater and our Herschel's crater. Keep in mind, so this is a great way to note which crater is which. So for myself, I'm going to remember that Herschel's crater is south and our unnamed crater is north. Uh, this might not necessarily be north and south, but the way it's oriented for me, it looks like it. So that's how I'm going to keep track. Now we're going to calculate how deep each crater is and the average slope. So what we have right now is a polygon that is defining an area and a second layer that is a raster with information contained within each cell. So what we're going to do is use a tool called Zonal Statistics to take this area that is defined by the polygon and take the information from the raster layers that falls within that area. And that the information that we're going to get from that is going to include our minimum and our maximum raster value, our range, our mean, standard deviation, majority, minority, and a bunch more information. So we're going to run this tool twice since we're interested in both the depth and the average slope. So what we're going to do, I'm going to shrink this down. I'm going to look up our tool, Zonal Statistics, as a table. Here, you're going to want this so that it creates a table for you to look at instead of creating a new layer, which will only have one option for the information it creates. And having the table just makes things a little bit neater. So we're going to open this up. We're going to, actually, I'm going to give you guys a chance to fill this out on your own. So go ahead and go do that. And when you come back, what I'm going to do is fill it out like so. So this feature zone data, this is going to be what defines our zones. I'm going to make that our craters. Oops. Going to clear my selection so that doesn't affect what we get. I'm going to tell it to choose from the name field because then it's going to give me two different records with all the information, one for our unnamed crater and one for Herschel's crater. And having the name is just going to make it easier for me to tell which one I'm looking at. Now, I'm going to do our average slope first. I'm going to do slope in degrees for our value raster. This is going to be the raster that it clips information from. And I'm going to name it crater slope Zonal Statistics table. Keep the statistics type as all so that it's going to calculate our mean, our max, our medium, minimum, percentile, range, etc. It's going to calculate all of those. And run. Okay. So now we have here in our standalone tables our crater slope. I'm going to go ahead and just run this one more time with the elevation so I can get the depth of the crater. I'm actually going to name this crater ETM. And run. Okay, so now I have my two tables. I'm going to open those both, bring up that data, and we're going to see here all our information for our slope and for our elevation. Now, what we're going to do now is check our results and make sure that everything looks right. So we have two different records, one for our northern crater and one for our Herschel's crater. And that's true for both of them. We're also going to see our minimum and maximum values. These seem to be making sense. So for our slope, we know that our maximum slope value was, I think, roughly 72. So having a max at 70 makes sense. It's not exceeding our slope. And this minimum makes sense because, we can see if we turn this craters off that our elevation shows that there is some part of it that's going to be mostly flat. So having very small numbers here will make sense. With our DTM, our maximum also does not exceed our maximum elevation values, and our minimum does not exceed that too. And it makes sense that it would be quite a big range since it is a crater, which means that it's going to have a high zone and then drop to a low zone in the middle. Okay, so now you can answer questions 10 through 13, which is asking you what your mean slope is of the northern crater and what your mean slope of Herschel's crater, the southern crater, is in degrees. So you can pull that from this table. Just make sure to keep in mind which one is the northern crater and the southern crater. Question 12 is about the depth of the northern crater. Now, keep in mind the depth of the northern crater, it's not asking what the elevation is at the bottom. It's asking how deep it is. So, in other words, it's asking what is the elevation change from top to bottom. Because I could tell you, say we had a very tall glass of water, right? Hypothetically. And we set it at ocean level. So its elevation at the very bottom is 0. But we don't care about the elevation at the bottom of the glass. We're caring about how deep the glass is. And if we say that the glass is like the size of the house, we're going to be able to say, like a single-story house. How tall is that? Let's pretend it's 15 feet tall. We're going to say that the depth of the glass is 15 feet. So essentially, what I'm dancing around here is that the depth that you're looking for is going to be your range. And questions 12 and 13 are just the depth of both the northern crater and the southern crater. Moving on, next we're going to do some area analysis in which you guys are going to calculate the area of both the craters in hectares. Give you a chance to do this on your own. You've done this multiple different times, calculating the area. If you need some extra help, I'm going to run through it really quickly here. Turn this back on. Attribute table. Going to add a field. Oh, whoops. Well, you can see where I went through and checked the instructions. I already have an area hectares field. So basically, you'll add this field, area hectares, make it float. I am going to just delete. Oh, goodness. Hold on. Delete these fields so we don't need them. Save. Back out here. You'll want to calculate your geometry and just make sure that's set up for area. I tend to stick with geodesic for most things. Area and hectares. Make sure it's set to the correct coordinate system. Just like that. And then run that, and you'll get this information. You can use that to answer questions 14 and 15. What the area is of the northern crater and of the southern crater. Next up, what we're going to do is edit the symbology of our elevation. So I'm going to turn off my craters, and I'm going to turn off my slope. So we're going to want to edit the symbology to make this look just a little bit nicer. I'm going to open up our symbology panel. You'll want your primary symbology set to stretch, so it stretches along a color ramp because this is a continuous raster. In your instructions, you have a page or two going over color schemes and picking color schemes and kind of different technical aspects of that. What we're going to do here is just pick a good color scheme for elevation on Mars. I'm going to tell it to show me the names. Scroll down here. I think I'm going to do this oranges continuous. And we'll see how that looks. Now, right now we have the lowest elevations as the lightest color, which isn't typically how your brain interprets things and what we see. So I'm going to click this to invert it. We're going to see that now I have this kind of system. So now the highest points are the lightest points, and the darkest is the darkest, or the lowest is the darkest values there. Some other things you can do, if you open this up again, come to format color schemes, is well, you can invert the color scheme here. You can also adjust like what the color bins are. So you could tell this to be transparent, for example, if you wanted to. Or in my case, I'm going to take out these three colors because I think it's just going to look a little bit better. So I'm going to come here, select this, and then just click delete on my keyboard. Alternatively, click here. You can come up to this black remove color button at the top. I'm just going to do that one more time. Click OK to apply that. And now I've got this this setup, which works better for me. I like that a little bit more. Then another note is that you can come up here to your raster layer tab on your main ribbon and adjust more of the appearance of this using your rendering, enhancement, and rotation sections up here. So you can find the symbology here, adjust the stretch type, which will just affect kind of what values it's counting along that stretch. For right now, keep it at percent clip. You can play around with your minimum, maximum, or standard deviation, and just choose the one that represents the data the best. For me, I'm actually going to switch it to minimum, maximum, so it includes the very end of the data set. You can also use a couple other things in here. For me personally, I don't feel the need to adjust anything up here for this particular imagery for this shapefile, so I'm going to leave everything else as is. All right, and that is it for exercise 8. So now what you have to do is submit or create a professional figure for the Herschel crater, which remember is going to be your southern crater down here. You need to include the hillshade and make sure your terrain model is transparent so that you can see the hillshade. Include a scale bar, data credits, and some kind of caption or explanatory title, or both, to tell the reader what they're looking at when they view the figure. You'll also want to submit your answers to the questions on the quiz on Canvas. And other than that, that's about it. So good luck to you all and happy mapping.